So welcome back. In this video, we are going to see the chapter 4, which have a more weightage about network security. So this is a huge security topic, and you need to remember a lot of port numbers where you will be expecting such type of questions in the CC certification exams. And once again, thank you to IC Square for providing such resource materials of the chapter 4 in CC. Not wasting much time, let's quickly start to the chapter 4, network security. So these are the modules we are going to cover. Understand computer networking, understand network threats and attacks, understand network security infrastructure, and under this we have domain mapping. So network computer networking, under this we have three subdomains. Understand network threats and attacks, we have four subdomains. Understand network security infrastructure, again we have four subdomains. Just understand the terminologies involved in this chapter. So first, we'll understand about the API. API stands for Application Programming Interface, a set of routines, standards, protocols, and tools for building a software application to access the web-based software application or a web tool. So I repeat, API stands for a set of routines, standards, protocols, and the tools for building a software applications to access a web-based software applications or a web tool. To understand this API in a real-time example, imagine you go to a hotel. So instead of directly going to a kitchen and ordering an item, a waiter will be there who is getting your order and informing to the chef will prepare, and again the waiter will collect from the kitchen and deliver it to a dining table. So the waiter is considered as a API. In every time when data is requested from a client end, this API calls will go to a server and fetch the an exact requested data and give it back to the client. So this way data transfer is fast and accurate, and the requested data from the client will be exactly delivered to the client from the server. Next we have a bit. Bit stands for most essential presentation of data. So it may be either a zeros or ones, and you can find this bits in the layer 1 of OSI. So OSI stands for Open System Interconnection Model. Then next we have a broadcast. Broadcast transmission is one to many, one to everyone form of sending internet traffic. The best example of broadcasters, FMs, or even the internet. If one net is getting broadcast, everyone will publicly can go and access or view that particular data. Then next we have a byte. So byte is a unit of digital information that is most commonly consists of 8 bits. So you can see 8 bit is considered as 1 byte. Next we have a cloud computing. Cloud computing is refers to a model to enable ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Example, networks, servers, storage, application, and services. And this can be rapidly provisioned and released with minimal management effort or a server service provider interaction. And you can refer more details about this NIST 800-165. Next we have a community cloud, a system in which a cloud infrastructure is provisioned for exclusive use by a specific community of customers from an organization that they have a shared concern. Example, mission, security requirements, policies, and complaints consideration. It may be owned, managed, and operated by one or more of an organization in the community, a third party, or some combinations of them, and it may exist on or off premises. And next we have a data encapsulation. An opposite process of encapsulation is considered as de-encapsulation, in which bundles of data are packed and rebuilt. Then next we have a denial of service, a prevention of authorized access to a resource or delaying the time critical operations. So maybe you have a server, and if an DOS attack got executed, it will stop other users to accessing the particular applications. That is considered as DOS. Then we have a domain name system. This acronym can be applied to three interrelated elements such as server, physical server, and internet protocol. Then next we have encapsulation. Encapsulation of the data ID and the code ID during all phase of software development and an operational use. Binding together data and the methods is a process of encapsulation. Its opposite process may be unpacking, revolving, or using other terms. Also used to refer to take any set of data and packing it or hiding it in another data structure, as it is common in network protocols and the encryption. Then next we have encryption, the process and the act of converting a message from a plain text to a ciphertext. Sometimes it is also referred to as encrypting. The two terms are sometimes used interchangeable in literature and have a similar meaning. Then we have FTP, a file transfer protocol, an internet protocol and the program used to transfer files between the host. Then next we have a fragment attack. In a fragment attack, an attacker fragments traffics in such a way that the system is unable to put data packets back together. Then next we have an hardware, a physical part of a computer and the related device. Next we have an hybrid cloud, a combination of public cloud storage and the private cloud storage, where some critical data resides in the enterprise private cloud while other data is stored and accessible from the public cloud storage provider. Next we have an infrastructure. So the provider of the core computing, storage and network hardware and the software, that is foundation upon which organization can build and then deploy applications. Infrastructure as a service is popular in data centers where software and servers are purchased as fully outsourced services and usually built on usage and how much the resources used. Then next we have Internet Control Message Protocol, ICMP, an IP network protocol standardized by the Internet Networking or Engineering Task Force through RFC 792 to determine if the particular service or host is available. The next we have Internet Protocol, a standard protocol for transmission of data from source to destination in a packet switched communication networks and interconnected networks of such networks. Then next we have a man-in-middle attack. Man-in-middle attack, an attacker where an adversary positions himself in between the user and the system so that he can interrupt and alter data traveling between them. Then we have microsegmentation, a part of zero trust strategies that breaks LAN into a small, very small, highly localized zones using firewalls or similar technologies. At the limit, this places a firewall at every connection point. The next we have a oversized packet attack, purposely sending a network packet that is larger than expected or larger than can be handled by receiving systems, causing a receiving systems to fail unexpectedly. Then coming with a packet, so packet is a representation of data at the layer 3 of the open system interconnection model. Then payload, it's a primary action of a malicious code attack. Then we have PCI DSS, stands for Payment Card Industry Security Standards. So it's a security standard that applies to a merchants and service provider who process credit card and debit cards, especially the banking entities comes under this PCI DSS. Next we have platform as a service. So web authoring or an application development middleware environment that allows application to be built in the cloud before they are deployed as SaaS assets. Then next we have a private cloud, a phrase used to describe a cloud computing platform that is implemented within a corporate firewall under the control of the IT department. A private cloud is designed to offer the same features and benefits of cloud systems, but removes the number of objections or objectives to the cloud computing model, including a control over enterprise and customer data. Worries about security and issues connecting to regulatory compliance. Then next we have a protocol, a set of rules, formats and the procedures is to implement and control some some type of association, that is communication between the systems. Next we have a public cloud. A cloud infrastructure is provisioned for open use by a general public. It may be owned, managed, operated by a business, academic and government organizations or some combinations of them. It exists on the premises of the cloud provider. Next we have Simple Mail Transfer Protocol, SMTP, the standard communication protocol for sending and receiving emails between the senders and the receiver. Next we have a software, computer programs and associated data that may be dynamically written or modified using an execution. Then next we have a software as a service. A cloud customer uses a cloud provider's application running within a cloud infrastructure. The application are accessible from various client devices through either a thin client infrastructure such as web browser or programming interface. The consumer doesn't manage or control the underlying cloud infrastructure, including a network and servers, operating systems, storage, or even individual application capabilities, with the possible expectation of limited user specific application configuration settings. Even you can refer this NIST standard 80145. And finally, the snooping. So it's a faking a sending address of the transmission to gain an illegal entry to a secure systems. And we have a TCP/IP model, which stands for Transmission Control Protocol or Internet Protocol model. So here the Internet Networking Protocol model created by IETF, which offer 4 levels of functionalities: thin layer, physical communication; internet layer, network to network communication; transport layer, basic channel of connections and connection exchanges of data between the host; and the application layer, where other protocols and user application programs make use of network services. Then we have a VLAN, a virtual local area network. Is a logical group of workstation, servers, and network devices that appears on the top of LAN despite their geographical distribution. Then we have a VPN, a virtual private network, which is built on the top of existing networks that can provide a secure communication mechanism for transmission between networks. And we have a WLAN, a wireless area network. WLAN is a group of computers and devices that are located in the same vicinity, forming a network based on radio transmission rather than the wired connections. A Wi-Fi network type is a type of WLAN. And we have a ZMAP, a graphical user interface, GUI, for a network security scanners, a open source application that scans network to determine everything that is connected as well as the other information. Next we have a zero trust, removing the design belief that the network has any trust space. Security is managed at each possible levels, representing the most granular assets. Even microsegmentation of the payloads is a tool for this model. Now we got a few terminologies related to a network security. Now we'll understand in the module wise. So here the learning objectives. So after completion of the objects chapter, as a participants, we will understand about the concept of network security, then recognize common network terms and models, and identify common protocols and ports and their secure counterparts, identify type of network threats and attacks, discuss common tools used to identify and prevent threats, identify common data center terminology, recognize common cloud service terminologies, identify secure network design terminologies, and finally practice the terminologies of and review network security concepts. So yeah, the first concept, the first module we are going to discuss is about types of computer networks. First is LAN, local area network. Second is WAN, wide area network. Third is WLAN, wireless local area network. Then VPN, virtual private network. Then EPN, enterprise private network, which is used in the enterprise level. Then PAN, personal area network, your Bluetooth. Then CAN, campus area network, especially used in campus or small area. Then MAN, metropolitan area networks, so used in big cities. Then SAN, storage area network, used to store for data. Then SAN, again system area networks, is to connect different systems. Then POLAN, passive optical local area network, where we'll be using an optical cables to connect this. And networking devices, we have hubs, switch, routers, firewalls, servers, printers, fax machines, gateways, repeaters, bridge, modems, access points, and endpoint. These are the various types of networking devices. And other networking terms: packet, port. Packet is a data which is getting transmitted over the internet. Then port, a port numbers. Then protocol, okay, a set of predefined rules. Then Ethernet, okay, it's a cable where you can connect for a network connectivity. Then Wi-Fi, it's a wireless medium where you can connect your devices. Then IP address, and a static or dynamic address which is assigned to all networking devices when it connects to an internet. Then MAC address, it's an address which is embedded in a Ethernet card. MAC address is a static and it never change. Then OSI models, we have two things. One is OSI or network models we can say, and next we have TCP and the IP model. And chapter takeaways. So here you will be understanding more about computer networkings such as IPv4, IPv6. So IPv4 stands for IP version 4, okay, which is 128-bit data, okay, and IPv6 is an advance of IPv4 and it provides a very larger address field and improved security and improved quality of service. Under module 2, understand network threats and attacks. So here under this type of network attacks, we have DOS, DDoS, then fragments, oversized packets, snooping, man-in-middle attack, code and SQL injection, cross-site request forgery, privilege escalation, and insider threat. All this type of web-based attacks we have seen in the previous chapters. This particular web-based attacks happens. Then types of network threats, we have snooping, DDoS attacks, virus, worm, Trojan. On path we have man in middle, slide channel, phishing, rootkit, hardware and spyware, and the malware. So under this module 2, so understand network threats and attacks. So here we have a list of the secure ports and the insecure ports. If you see, I personally recommend to boycott this or memorize this port numbers along with the protocols. So in the exam, it will help you to give a correct answers. So 21, the port number is 21 port number belongs to FTP, which is an insecure file transfer protocol, and the secure port is 22, which helps to share the secure file transfer protocols. Then next we have a telnet, which is running on port number 23, and the secure port is 22 SSH, which is a secure SIP. And we have SMTP, Simple Mail Transfer Protocol, at 25. Here secure alternate port is 589, so SMTP with TLS. And 37 is a time protocol, and 123 is an NTP, network time protocol. And 53 DNS, domain name service, and here 853 DOT, DNS over TLS, and 80 HTTP hypertext transfer protocol, and 443 HTTPS hypertext transfer protocol with the secure SSL and the TLS. Then 143 IMAP, so Internet Message Access Protocol. Here 993 IMAP, which stands for Internet Access Message Protocol for SSL and TLS. And 161 162 SNMP, Simple Network Management Protocol. 161 162 SNMP version 3. And we have 445 SMP, Server Message Block, and 2049 NFS, Network File Systems. And we have LDAP, Lightweight Directory Access Protocol, and LDAP-S, which is a Secure Lightweight Directory Access Protocol. And how to identify threats, we have IDS, NIDS, which is Intrusion Detection Systems, then NIDS, Network Intrusion Detection Systems, and HIDS, Host-Based Intrusion Detection System, and SIM, Security Information and Event Management Tool. It's a log management tool. And how to prevent threats, we have an antivirus tools, and scans, and firewalls, IDS, IPS, NIPS, HIPS. Then understand network security infrastructure. So under this module 3, you need to understand a clarity about requirements of data structure or data center. So here how a power will be managed, HVAC, okay, so heat, ventilation, okay, air conditioning, then fire suppression systems, then redundancy, MOU and MOA, then cloud service model, software as a service, infrastructure as a service, and platform as a service. And we have a cloud deployment models, public, private, community, and the hybrid. Then we have network design terminologies. Under this we have network segmentation, example micro segmentation and demilitarized zone. And we have virtual area, local area network, VLAN, and virtual private area network, VPN, and defense in depth, zero trust, network access control. And this is a diagrammatic representation of OSI model. So here we have an application layer, the next will be the presentation layer, the next will be the session layer, the next will be the transport layer, and next will be the network layer and data link layer and the physical layer. So from the above diagram you can see the application is a place where user interacts, okay, where we see using an applications like Google Chrome, Google Meet, or a Gmail, all those things. Then back of it the presentation layer exists. Under that a session layer which handle different sessions. The transport layer is there which helps to transfer the packets. Then the network layer which helps to redirect the correct path the data flow happens. Then the data link layer, okay. Then finally the physical layer which handles only the bit zeros and ones, which is connected via Ethernet cables, okay, or wireless medium where a bits is getting transmitted. And the next we have a TCP IP model. So here we have, okay, here we have OSI models. If you see the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and the physical layer. But in the TCP/IP protocol architecture, the application layer, presentation layer, session layer, They merge together and form a single layer known as application layer. Then transport layer still remains the same, and network layer is converted into internet layer, and data link layer and the physical layer is converted into network interface layers. Then we have a TCP and IP protocol suite. Under this we have FTP, Telnet, SNMP, LDP. So these are the protocols used in just such layers. Then TFTP, SMTP, NFS, X Windows. Under this we have TCP, UDP. So IGMP, IP, ICMP, and Ethernet, fast Internet, token ring, and FDDI. So now you got a clarity like what type of protocols is used in what type of layer. Okay. So we came to this end of this chapter 4. So here you need to focus more about on the protocols and the port numbers and the OSI layer and the TCP and IP layer. So this chapter consists of more weightage. We want to thank IC Square for offering such a short, valuable resources. Catch you in the next chapter.